integral calculus, right? That is integration. And integration now is sometimes called anti-derivation, right? Anti-differentiation, because it's like the reverse of what differentiation is. If I differentiate this function now and I get an answer, right? If I have to get the original function that was differentiated to get an answer, I'll have to integrate my answer to get the original function, right? From the previous video where we talked about differentiation from first principle, we differentiated this function, right, using first principle, and our answer for the y, the x was 6x, right? 6x. After differentiating this function, y equals 3x squared, we got an answer of 6x. Now, if I'm to get the original function which gave us this differential, I'll have to integrate my differential, right? And we usually represent integration rather with this sign. This is the sign for integration, right? So I'm going to have to integrate this 6x with respect to x, right? I'm integrating 6x with respect to x to get the original function. Now this is how integration goes. We're going to add 1, right? I'm now carrying out the integration. The power of x here happens to be 1, right? So I'm going to add 1 to the power of this x. Then whatever we get, 1 plus 1, that's 2, right? I'm going to divide with 2. So this is going to be 6x squared. Since 1 plus 1 is going to be 2, right? Divided by the same 2. Now 6 can be divided by 2, so our final answer is going to be 3x squared, right? So y is going to be x. This is the original function that gave us this differential 6x.
Excuse me, I have a question. Are we always going to be adding like 2 or something?
Okay, like, you're asking why we added 1 here.
Yes.
Okay, so let me see if I can explain your question. Now you see, I said integration is like the reverse of differentiation, right? So if you observe, when we are differentiating this function as y equal to 3x squared, these are the two operations we carried out. We carried out multiplication and subtraction, right? Multiplication in the sense that we multiply the power of x with the coefficient of x, that is 2 and 3, which gave us 6, right? We carry out multiplication. Then this is the subtraction we carried out, minus 1. We reduce the power by 1, right? By just 1. That's why we are now adding 1. We are always reducing by 1, so we are always increasing or adding 1 while integrating. You get the point? Now, so since we reduce this 2 by 1, gave us 1. When I want to now integrate this function, that is 6x, to get the original function, I will have to add that 1 back, right? So the operation now we're going to be carrying out for integration won't be multiplication and subtraction. It's going to be addition and division, right? It's the opposite, the reverse of what we did in differentiation. Multiplication, subtraction, addition, and division. Where did we carry out this addition? Where we added 1 to the power of 6x. The quotient of x happened to be 1 here, right? Then we added 1, right? Unlike differentiation. Then after adding 1, we got 2 as the new power for x. What did we do with the 2? We divided with that 2, right? So that's how easy it is to add and divide, right? Alright, so next up, we're going to do this. We're going to differentiate these other two functions and try to integrate them, right? So we get familiar with integration. Now, I'm going to try to use this medium to complete what we didn't finish in the previous video. I'm going to differentiate the second function with first principle. And the answer I'm going to get, I'm going to integrate it, right? To see if I'm going to get the original function. Alright, so the function we have there is y equals to 2x squared plus x, right? I'm going to differentiate this using first principle, then try to integrate it back. So, what's the first principle? There was a formula I gave to us on this channel for differentiation using first principle. All that I said changing y over changing x. This is another way of expressing or writing dy dx is equal to f of limit as change in x approaches 0 for f of x plus change in x minus f of x over change in x, right? So this is the formula for first principle differentiation. So first of all, what we have to do is get f of x plus change in x, subtract f of x from it, then you divide the change in x. whatever you get, you take your limit as change in x approaches 0. So this is our f of, okay, this is our f of x, the original function, that's our f of x. This one here is a function of x, right? F of x there happens to be 2x squared plus x, right? That's our f of x. So what is our f of x plus change in x? Now it's going to be similar to this, just that anywhere you have x, you replace it with x plus change in x, right? So this will be 2x plus change in x squared plus x plus change in x, right? So we have gotten two equations. The first one is f of x, the second one is f of x plus change in x. To this substitution. So from this formula, you see that f of x is subtracting, f of x plus change in x is subtracting f of x, and subtraction going on there for you divide with f of x. So let us carry out that subtraction. F of, and I'm just going to go straight to the subtraction. This will be 2x plus change in x squared plus x plus change in x minus, right, this subtracting this, minus 2x squared plus x, right? This minus this, right? So before we proceed with the subtraction, let's open these brackets. Let's see that expand this bracket. Right? So opening this bracket, x plus change in x squared, we are going to have this x plus change in x multiplying another x plus change in x into two places since we have square there. If we have something like q, we will multiply in three places, right? So now x times x, that's x squared, right? Then x times change in x, that's x change in x. Change in x times x, that's x change in x, right? Though you may feel like writing it as change in x, right? That's change x times x, change in x, but the proper way to write it is x change in x, right? Then finally, change in x times change in x, that is going to be change in x squared, right? So this bracket, this is what we have, x squared change in x, okay? So what are we going to do? Sum everything up. What are we going to have? We're going to have x squared plus, since we have x change in x change in x in two places, we're going to have a total of 2x change in x, right? Plus change in x squared. So expanding this bracket is what we have. So let's impute this into our equation and so into our subtraction rather. So this is going to be 2. And this bracket which will expand is what we call x squared plus 2x change in x plus change in x squared, right? That's what this bracket is. So we're going to have plus x plus change in x. And I'm going to also open this bracket with this negative sign. So this will be negative 2x squared, right? And this is also going to be negative x, right? Negative. Now there is no, okay, there is one more bracket to open as this one now. We're going to open this bracket with 2. We have 2 here, we're going to open this bracket with 2. So 2 times x squared, that's going to be 2x squared, right? Then 2 times 2x change in x, that's going to be 4x change in x, right? Finally, 2 times change in x squared, that's going to be 2 change in x squared, right? There is no bracket, so open the bracket. So we have plus x plus change in x minus 2x squared minus x, right? So let's see if we can simplify this further. Now we have 2x squared, right? 2x squared minus 2x squared. So this is going to subtract this out, right? Then we have x minus x, right? Is there any other subtraction? No, there is no other subtraction. So we are left with these three things. So let's do this with them. 4x change in x, 2x, okay, 2 change in x squared, and change in x. So let's see what we have. We have 4x change in x as this, plus 2 change in x squared, right? And changing x. Alright, so what we've gotten here is just the subtraction. That is f of x plus changing x minus f of x. We've just gotten the subtraction. Now we're going to divide this subtraction, this value we've gotten, with changing x, right? Let's divide this with changing x. I'm going to divide this with changing x, right? Dividing this now with changing x. So how do I cancel out changing x? First, I have to factor out changing x, so I can use to cancel out this one, right? So I'm going to have changing x. If I factor out changing x from 4x changing x, I'll be left with 4x, right? If I factor out changing x from 2 changing x squared, I'll be left with 2 change in x, right? Then if I factor out changing x from changing x, I'll be left with 1, right? So this is the factorization of change x from this expression, all divided by change in x. So now change in x can cancel out change in x, right? So we are left with 4x plus 2 change x plus 1, right? And now there is no further simplification, like there is no further simplification of the here. So we can start taking the limit as change x approaches 0, right? Let's just take the limit because change in y over change in x is going to be equal to the limit of this function now as change in x approaches 0, right? So we are going to substitute change in x for 0. If we find any change in x, just substitute it to 0, right? So change in y over change in x is going to be equal to 4x plus 2 times change in x, so still is 0, right? So 2 times 0 plus 1. So our final answer is going to be 4x plus 1, right? So if you differentiate this function y equals to 2x squared plus x, this should be your answer. I know the method is long, but you just have to use this medium to complete the previous video. You can just go ahead with the normal differentiation method, not very specific, right? So now that we've differentiated this function and gotten the value x to be 4x plus 1, let's now go back to our topic of today, which is integration, right? So we're going to integrate this to see if we get the original function, right? So let's see, we got the y there, the differential we got there was what? The differential was 4x plus 1, right? Now I want to apply integration to see if I'm going to get the original function for y, right? So I'm going to integrate the y x, right? And how am I going to do that? I'm integrating the differential, which is 4x plus 1. I'm integrating this with respect to x, right? So if I integrate the y dx, I'm going to get y, everybody knows, right? And if I integrate this, how am I going to integrate this? By carrying out just 2 simple steps, right? Addition and division. Addition and division, right? Unlike differentiation where we carried out multiplication and subtraction. Now how do we do this? The coefficient of x here, for this, there are 2 terms here, 1, 2. But the coefficient of x in the first term is 1, right? The coefficient of x here happens to be 1. So if I add 1 to 1, it's going to become 2, right? So it's going to be 4x raised to power 1 plus 1. I'm adding 1 to the power of x, which is already 1, right? So that is going to give me 2. That's for the addition. Now for the division, whatever answer I get here, be it 2 or whatever I get, I'm going to divide the whole term there with that answer. So I'm going to divide by 2, right? You know 1 plus 1, adding 1 give us 2. And I'm dividing with that 2. That's for the first term. Now how about the second term? There is a second term there which is 1, right? What is the coefficient of x there? The coefficient of x there, since you're not seeing any x, it's actually 0, right? That's like 1x raised to power 0. That's what you actually get. The coefficient of x there is 0. So if we are to integrate this term, this term here 1, what are we going to do? We're going to add 1 to the power of x, which is currently 0, right? So if I add 1 to the power of x, which is 0, I'm going to get 1, right? You know, x was previously having a power of 0 there. Now I'm adding 1 plus 1. I'm adding 1 to that 0, giving us 1. So now x is appearing in the equation, right? So now I'm going to also divide it by the power, which is 1. I'll divide it 1, right? Usually we don't represent this the power of 1 or equation of 1, or you just don't represent 1. But you should notice the presence of 1 here, the power of 1, and we divide it with 1, right? So now this will be the answer, or we can carry the division here. So finally, y is going to be equal to 4 divided by 2. That's 2, right? 2x squared plus x, which is the final answer because so if you integrate this function, you're going to get this 2x squared plus x, right? That's actually the original function. We differentiated to get the differential, and we integrate the differential to get the initial function, right? Hope this is clear. Alright, so let's go to the board and last one. Alright, so the third question is actually going to be a bit different from what we're doing normally. I'll explain why. Okay. Now the third question, we have this, the third function, we have that y is equal to x raised to the power 3 minus 5, right? I'm not going to differentiate this using text ratio, but you can try that out. Let me just use the general differential method. So this is going to be y dx equal to the coefficient of x happens to be 1, right? So 3 times 1 is going to be 3x. Then we're going to reduce the power by 1 as well. So it's going to be 2. No, 3 minus 1, that's 2. Minus, now if I differentiate 5x, I said it before on this channel that whenever you differentiate the function, you get 0, right? Why? Why are you always getting 0? Because the coefficient of x there is actually 0. The coefficient of x here is actually 0. Since you're not seeing the x, you get the points, right? So now let me assume this the x is actually there, which is actually there, but I want to differentiate it like this one. I'm going to say 0 times 5, which is 0, right? And 0 minus 1, which is x raised to the power negative 1 now. At the end of the day, 0 times x is still 0. So without going through all these processes, just have it in mind that whenever you differentiate a constant, your answer is 0, right? So I'm going to base this as it is not necessary, right? Whether the constant is 501, using 501, right? You differentiate it, you get 0, right? 517, you still get 0. 11,806, you get 0, right? And the constant we have there is 5. If you differentiate that constant, you get 0, right? So now this is the differential of this function. Can we integrate this to get the initial function? Let's try. I'm going to try to integrate the y, the x, right? By integrating the differential, which is 3x squared with respect to x, right? So if I integrate the y dx, I'm going to get y. Let's now integrate this. I'm going to add 1 to the power, which is 2, right? You add 1 to the power is currently 2, you add 1 to it, it becomes 3. Then you divide that 3, right? So what's going to be the final answer? Y is equal to 3x, okay? 3x raised to the power 3 divided by 3, right? So this 3 is going to cancel this 3, and our final answer is going to be y equal to x raised to the power 3. Leave by now you should spot the difference. Now, for the other integration, we got the exact value for the original function, right? 2x squared plus x. But now, see what we're getting. We're getting just x raised to the power 3. We're not getting the constant part. We're not getting the constant, right? Now, we're going to go more into this. I think under integration, we have definite integrals and indefinite integral. Now, this integration I've done so far actually falls under indefinite integral, right? You can see after doing the integration here, we didn't get the definite value for the original function. This is how we usually come out with that law in mathematics, by adding c or k, right? After integration, do well to add c or k, or c or plus k, right? To represent the constant which we don't even know, right? Which you can't get using normal ordinary integration, right? That's to say that for the other integration we actually carried out, it was necessary or it was proper to add k or c after integrating, ensure you add K or C, because there might have been a constant here, maybe 16 or something that we missed, that we couldn't get back using integration, right? So whenever you integrate, whenever you're carrying out indefinite integrals, make sure you add K or C to represent the constant that might have been in the original function, right? So that will be it for this video. We're going to look into indefinite integrals next time in the next video on this channel, right? This is actually indefinite. Everything else is just indefinite. We're going to look at definite on the next video, right? But if you haven't subscribed and you're still watching, please do it to subscribe, like the video, share.